Good morning, ladies and gentlemen. Hi everyone. Welcome to MECnIT 2020. I am Abdurrahman Ridho from University of Sumatera Utara, and today I would like to talk to you about my paper, Optimization of the Gronsfeld Cipher Key using Okamoto Uchiyama Public Key Cryptosystem for Data Security. And as you can see here, these are the writers for this paper, and I want to start my presentation now. So here is the abstract. As you know, the security is an absolute thing that must be met in various aspects of life, including computers, and cryptography is present as one of the methods are continually being developed in computer security. And Okamoto Uchiyama Cryptosystem is part of cryptography, and modifications required as the development is expected to provide an increase in the level security. Research in this paper shows results comparing the time used to execute between Gronsfeld Cipher and Gronsfeld Cipher with key optimization Gronsfeld Cipher using Okamoto Uchiyama Cryptosystem. And for the result is between 0.0030 until 0.0040 seconds for Gronsfeld ciphers and up to 0.0050 seconds for Gronsfeld cipher with key optimization using Okamoto Uchiyama. So here is some introduction of my paper. So the first introduction is we need to make a little contribution to the security. So that's the main point of my research, because any small development must still be done because it can be a reference for future progress to come. So in next slide, this slide, we know that there are two cryptography. There is symmetric and asymmetric cryptography. So in symmetric cryptography, there is one method that we use in the science of cryptography. But I see in here there is a weakness, because the sender and the receiver need to make an agreement to establish a single key that can use, the key. The sender and receiver need to make an agreement about the key to protect their things. So I want to make a combination between symmetric cryptography and asymmetric cryptography. Gronsfeld cipher is symmetric cryptography and Okamoto Uchiyama is asymmetric cryptography. And the main point of this combination is I want to make optimization in the key of Gronsfeld cipher. So here is some history about Gronsfeld cipher. You can see here Gronsfeld cipher is a development from Vigenère cipher. The key is composed of number which indicated by an amount which forwarded to alphabet letters, where encryption is done from plain text to cipher text. And why I use Okamoto Uchiyama? First, this cryptosystem is trapping and different from its predecessors such as Rabin RSA and Diffie-Hellman, and then this the sim of is probabilistic, and then probable security, semantically secure. Its speed can be compared with the elliptic curve cryptosystems acquire the property homomorphic, and anyone can change the ciphertext plaintext into ciphertext another but not replaced. We can see here in this slide about the same of optimization Gronsfeld cipher's key using Okamoto Uchiyama is where first we put the plaintext and then we put the key using Gronsfeld cipher, and then we send the key to the next part. We make an encryption for the key using Okamoto Uchiyama, and we got the cipher key. And then we send the cipher key and the ciphertext to the receivers, and the receivers will decrypt the cipher key first using Okamoto Uchiyama to get the real key of Gronsfeld cipher. Why does the receiver need to decrypt and get the key? Because the key is in Gronsfeld cipher, and then the receiver will get the plain text. And here is the result. I make a comparison between the cipher. This is the table about the experiment using the key chart, using 3 digits, but with only Gronsfeld cipher. Table 1 with 3 digits and table 2 is 10 digits. And as we can see here, the average time is between 0.0041 until 0.0032. So it's not so far. And the last is the result tables with experiments using optimization of the Gronsfeld cipher's key using Okamoto Uchiyama public key crypto system. In the table 3, we can see I use 3 digits, and in table 4 I use 10 digits. Yeah, we can see over there. In table 3, the average time is 0.0050, and then in table 4 is 0.0051. So if we make a comparison between table 1, 2, 3, and 4, or we make a comparison between raw experiment using Gronsfeld cipher only and the optimization, we can see there is the time seconds is increased. So here is the conclusion. The modifications were made using Gronsfeld cipher with Okamoto Uchiyama can run well, and the execution between the experiments using Gronsfeld cipher and Gronsfeld cipher key optimization using Okamoto Uchiyama. The difference in time, is not too different. The private key is selected based on algorithm Gronsfeld cipher encrypted longer produce numbers by using Okamoto Uchiyama, expected to complicate solving performed by unauthorized entities. That's the main point. And the length of the key and plaintext is, of course, has an effect to the time of execution. Okay, so I think thank you for listening. Thank you very much.